Okay, so today we are going to work on section 10.5. So this section's a little bit different from everything that we've been doing. We are obviously going to be working with that stuff, with simplifying radicals and everything. But 10.5 actually deals with the Pythagorean Theorem. Now, hopefully we all know about the Pythagorean Theorem. We've probably done the Pythagorean Theorem before, but we are going to be doing a little bit more in-depth stuff with it today. So the Pythagorean Theorem, if we don't remember, the Pythagorean Theorem is when we are working with a right triangle. That's a terrible right triangle, and I'm going to redo that in a second. But when we are working with a right triangle, that's a little bit better. And only when we are working with a right triangle. Okay, and we know that it's a right triangle when we have one side being exactly 90 degrees. And this little box here, this box tells us that this triangle is a right triangle because this is a 90-degree angle. So when we have our triangle here, just let's quickly go over some of the parts of our triangle. First off, the two sides that create this 90-degree angle, we call these the legs. Okay, these are my legs. The side that is directly across from the 90-degree angle, this is called my hypotenuse. All right, my hypotenuse. So we have to remember those two terms. We have to know that our legs are the two parts that make up the 90-degree angle. And my hypotenuse is the side that's directly across from the 90-degree angle. So now that we're talking about the Pythagorean Theorem, okay, the Pythagorean Theorem states that when working with a right triangle, the square of the lengths of the hypotenuse is equal to the sum of the square of the lengths of the legs. So let's put that into some easier terms to work with. If we call my legs A and B, and we call the hypotenuse C, all right, the definition says that the sum of the squares of the lengths of the legs, so A and B, taking A, squaring it, taking B and squaring it, and using the sum, we would get A squared plus B squared, and that is going to equal the hypotenuse squared, so C squared. So that is what our Pythagorean theorem says, that A squared plus B squared equals C squared. Again, it doesn't matter what leg we call A and what leg we call B, as long as one leg is A and one leg is B, and the hypotenuse is always C. As long as those things happen, then we're fine. Then we're okay. All right? So there's a couple things that we could do with our Pythagorean theorem here. The first thing is we can find the missing length of one of our legs, or the hypotenuse as well. So let's say we had our right triangle here. All right, we have a right triangle. And we know that it's a right triangle because of the right angle box here. And we're told that this leg here, this is 10 units. And this leg here is 24 units. And we want to solve for C. We want to solve for the hypotenuse. Well, since we know that this is a right triangle, the length of the legs will always follow Pythagorean's theorem. So I am able to say, all right, A squared plus B squared will have to equal C squared. A and B are just the two lengths of the legs. So in this case, we're going to call 10A and we'll call 24B. Again, it wouldn't matter if we had called 10B and 24A as long as we work with the two legs. All right, and again, we know that these are the legs because these are the two sides that make up the 90-degree angle. Those are my two legs. So what I can do is I can input my 10 for A, so I'll have 10 squared. I can input my 24 for B, so I'll have 24 squared. And we still don't know what C is, so we'll leave it as C squared. Okay, so now I'm just going to go and solve this. I know that 10 squared, that's 100. 24 squared, if you don't know it, we can put it into the calculator, but that's going to be 576. And C squared, I can't really do anything with it, so I leave it as C squared. I then add these two together, 100 plus 576. That's going to be 676. And that's going to equal C squared. But the thing is, I need to know what C is, not C squared. So, in order to get rid of a square, kind of the opposite of like what we were doing when solving it, if we wanted to get rid of a square root, we squared it. Well, to get rid of a square, we're going to square root both sides. So when I square root C squared, I'm just left with C, because the square and the square root will essentially cancel each other out. Then here, the square root of 676, I'm going to have to look to solve or simplify that. But in this case, we can kind of just plug this into the calculator because 676 actually is a perfect square. So the square root of 676 is going to be 26. And then that would be my answer here. My answer would be C is equal to 26. All right, so let's try another one here. Let's say that we have our triangle here going this way instead. But we still know that it's a right angle or a right triangle. We see our right angle sign here. Let's say that this side here is 7 units. This side is 15 units. And then this side we'll call x units. So again, we want to solve here for x. We want to solve for the missing leg. Now again, I know that that's a leg because these right here are my two legs. These are the parts that create the right angle. So since these are my two legs, it doesn't matter. We'll call this one A. We'll call this one B. Which then leaves my 15 as C. So if I go to Pythagorean's Theorem, A squared plus B squared equals C squared. I plug in my A. In this case, my A is x, so I'm just going to have x squared. My B is 7, so I'm going to have 7 squared. And my C is 15, so I'm going to have 15 squared. Now I just simplify what I can. 7 squared gives me 49. X squared I can't really do anything with, so I leave it as x squared. And 15 squared, that's going to equal 225. Okay. Now, unlike the last problem where I already had the variable by itself and I didn't really have to do anything, here I don't. Here I have to get the x squared by itself. So in order to get the x squared by itself, I'm just going to subtract the 49 from both sides first. All right. In order to solve these, we have to make sure that the variable is by itself. So the 49s will cancel out. 225 minus 49 is going to give us 176. So we're going to end up with x squared equals 176. And just like we were saying before, if I want to get the variable away from the square, in order to get rid of a square, we want to square root it. To get rid of a square, we square root. So the square root and the square cancel out, and we are left with just x. Now here in the directions, let's actually say that instead of trying to simplify this, let's say that I wanted to round it to the nearest hundredth, let's say. Okay, which I may ask you to do sometimes. I may also ask you to simplify, though. In this case, let's round it to the nearest hundredth. So all I have to do is in the calculator put in square root of 176, and I'm going to get approximately 13.27. All right, and again, I say approximately because it's not exactly. This is an estimate. So my answer is then going to be 13.27. Okay, so on the screen I have given you two different triangles. I want you to try and do these on your own. Pause the video here. Again, take about 5 minutes. Try and solve the missing side. And for the directions on this one, we'll say round to the nearest hundredth. If you don't remember, hundredths place values are 2 decimal places. So we're rounding to do 2 decimal places. So try this on your own. Pause it here. And once you unpause, you should see the answers. Alright, so hopefully, now that we're back, you got these answers here. For this problem here, 6 and 8 were both my legs. So we called the 6a, we called the 8b, and this is my hypotenuse, so the y would stay as y squared. 6 squared is 36, 8 squared is 64. Add those together, you get 100. Ooh, excuse me. Take the square root of both sides. Square root of 100 is 10, so my y would equal 10. Over here, 12 is one of my legs. Z is the other leg, and 16 is my hypotenuse. So it's going to be 12 squared plus z squared equals 16 squared. 12 squared is 144. 16 squared is 256. Sorry about that. Then 144 plus z squared equals 256. Subtract the 144 from both sides. So the z squared equals 112. Take the square root of both of those, and we do end up with z being equal to approximately, this should be approximately, 10.58. So hopefully we are understanding our Pythagorean theorem and solving for any of the missing sides. Now do remember that we can only do this with a right triangle. So one more thing that I do want to talk to you about our right triangles, and it kind of goes along with something that a lot of people will kind of say just on their own here. Whenever we have a triangle, okay, especially a right triangle, the longest of the two sides will always be the hypotenuse. The hypotenuse is always the longest side, no matter what. Okay, so if you're just given a list of 3 numbers and you're told that those 3 numbers are the 3 sides of a right triangle, something like 4, 8, and 13, you know right away that 13, because it's the biggest number out of the 3, that is going to be your hypotenuse. All right, the biggest number is always the hypotenuse, no matter what. The two sides, like I said before, the two sides can be either of the 2 numbers. So if I wanted to make this side the 4 and this side the 8, that's fine. If I wanted to make this side here the 8 and make this side the 4, that's fine. It doesn't matter. The hypotenuse is always the longest side. The other 2 sides will just be the legs. All right, that's actually very important to understand, especially when working with like word problems. And it tells you something like the longest side could be this and the shortest side could be this. Well, we now know that if it tells us the longest side, that'll always be the hypotenuse. So, continuing with our Pythagorean theorem concept here, instead of trying to find a missing side of a triangle, we could also be asked if the 3 numbers that we're working with create a right triangle. Meaning, I could say something like, determine whether the sides with the length of 9, 12, and 16 are the lengths of the sides of a right triangle. Okay, so if this is the question that we're asked, we have to determine, is there a way that we can tell if those three sides fit a right triangle? Well, it's very simple. If they give us three sides, those three sides have to follow Pythagorean's theorem in order to be a right triangle. Meaning, if we put them into a squared plus b squared equals c squared, and we see that both sides are the same, then we know that this is a right triangle. But if we plug them in and we see that both sides are not the same, then this is not a right triangle. It would be some other type of triangle. So let's test it. When they give us three sides, all we have to do is plug it into Pythagorean's theorem. But now, like I was saying before, the one thing that's most important here is which side is going to be the hypotenuse. That is the most important part of this because the hypotenuse has to be C. A and B are interchangeable. C is not. C has to be the biggest side. So the first thing I say is, which is the biggest number between 9, 12, and 16? Well, obviously 16 is. So 16 will be my C. I don't care about the other two. It doesn't matter which one is A and which one is B. So for this one, we'll call the 9A, and we'll call the 12 B. So I take each of these three numbers and I plug it into Pythagorean's theorem. So I'm going to have 9 squared plus 12 squared. And we have to see, does that equal 16 squared? So now I just simplify what I can. So 9 squared, that's going to be 81. 12 squared, that's 144. 16 squared, that's going to be 256. Then I'm going to add 81 and 144, and I should get 225. And now I have to ask myself, well, does 225 equal 256? And obviously it does not. So because my two sides do not add together, they don't equal the same thing, this is not a right triangle. All right? In order for it to be a right triangle, both sides would have to be the same. They would have to be equal to each other. So this would be considered a non-right triangle. So I've put up two other pairs of possible right triangles here. So I want you to determine, are these the lengths of a right triangle or not? So are 30, 40, and 50 the lengths of a right triangle? And are 6, 12, and 18 the lengths of a right triangle? So pause the video here, take 5 minutes, see if you can determine whether they are right triangles or not. So as we see here, the first one, my C, my hypotenuse, is going to be 50. My A and my B are 30 and 40. Plugging it into Pythagorean's theorem, 30 squared plus 40 squared should equal 50 squared. 30 squared is 900, 40 squared is 1600, 50 squared is 2500. 900 plus 1600 is 2500. These are the same. They equal each other. So this is a right triangle. Now on the other hand, over here, 6 is going to be my A, 12 is going to be my B, 18 is my hypotenuse. It's the highest side, the biggest side. So 6 squared plus 12 squared equals 18 squared. 6 squared is 36. 12 squared is 144. 18 squared is 324. And 36 plus 144 is 180. And 180 does not equal 324. So this one's not a right triangle. So again, if I ever ask you to determine if these three sides are the sides of a right triangle, just plug it into Pythagorean's theorem and see, does it work? Does it make sense in Pythagorean's theorem? So now for the last part of this, I'm actually going to come back to this previous problem that we did where we wanted to determine if it was a Pythagorean theorem or not. So the next part we want to actually talk about is, not only can I ask you, is it a right triangle, I could also ask you, is it a Pythagorean triple? And you know what, we're actually going to go to these two problems. We're going to come back to these problems here. So, but again, I want to know, is this what we call a Pythagorean triple? All right. So, in order to be a Pythagorean triple, first of all, it has to be a right triangle. It has to follow the Pythagorean theorem. So right off the bat, if we were working with these two problems and I asked you, are they Pythagorean triples, I would know that this one can't be because it's not a right triangle. All right, so for it to be a Pythagorean triple, it has to have two things. First off, it has to be a right triangle. Okay, and again, in order to determine that, use the Pythagorean theorem. Okay? So if it's a right triangle, the second thing is that all three numbers, or all three sides, must be whole numbers, or counting numbers. Now what I mean by that is no decimals, no fractions. So in the case of this one here, 30, 40, 50, this would be a Pythagorean triple because not only is it a right triangle, but 30, 40, and 50 are all counting numbers. So not only is this a right triangle, we would also say that yes, this is a Pythagorean triple as well. Okay? An example of something that may not be a Pythagorean triple would be something like if I had the problem, give me a second to pull one up here. If I had the problem where I wanted to determine if the sides 8, 31.5, and 32.5 were a right triangle, and are they a Pythagorean triple? So, in order to do that, first, I want to determine, are they a right triangle? Because I need to know if they're a right triangle first. If they're not a right triangle, then they're obviously not a Pythagorean triple. So, if I go by my numbers, this is the biggest number, so that's going to be C. And we'll call this number A, and we'll call this one B. So based on Pythagorean's theorem, A squared plus B squared equals C squared, we go and we plug in our A, we plug in our B, and we plug in our C. So 8 squared, that's going to be 64. 31.5 squared, we would want to do that on a calculator. That's going to give us 992.25. And 32.5 squared, that's going to give us 1056.25. So I'm going to add 992 to 64, and I'm actually going to get 1056.25. And I see that both sides are equal to each other. So yes, this is a right triangle because it follows Pythagorean's theorem. But if I go over here and ask myself, well, is it a Pythagorean triple? Well, yes, it follows a right triangle, so the first part of it is correct, but then I look at my numbers, 8, 31.5, and 32.5. Those are not all counting numbers. 8 is, but 31.5 is not, and neither is 32.5. So because not all three of my sides are counting numbers, this is not a Pythagorean triple. All right, so you can have something that's a right triangle, but that's not a Pythagorean triple. So again, here's two more. And in these two problems, I want you to determine two things. I want you to first determine, are these the sides of a right triangle? And then secondly, I want you to also determine, are they a Pythagorean triple? So again, take about 5 minutes, pause the video here, do these problems, and then unpause it, and hopefully you get them all correct. So here are the answers for the two problems. For the first one, again, 41 is my hypotenuse. So 9 and 40 are my A and my B. 41 is my C. I plug it all in. 9 squared is 81. 40 squared is 1600. 41 squared is 1681. 81 plus 1600 does give me 1681. Both sides are the same, so that is a right triangle. And I know that this is a Pythagorean triple because if I look back at my numbers, all three of these numbers are whole counting numbers. So this is yes to a right triangle and yes to a Pythagorean triple. Now over here, this one may have been a little bit more difficult for you, but really it's not too bad. We do have to determine which one of these is the biggest, so you may want to plug it into the calculator just to get a decimal approximation of each of these. And if you do that, you realize that the square root of 97 is the biggest number. So this is going to be my C, this is my A, and this is my B. So when I plug it into Pythagorean's theorem, if we remember, when I take the square root of a number and square it, the square root and the square actually cancel each other out, and I'm left with just the radicand. So here, the square root of 65 squared is just 65. The square root of 97 squared is just 97. The only one that's a little bit more difficult here would be this, 6 square root of 2 squared. Because you have to remember to square both the 6 and the square root of 2. So 6 squared is 36. Square root of 2 squared is 2, and 36 times 2 is 72. But then when I take them and I add them up, 65 plus 72 is 137, and 137 does not equal 97. So no, this is not a Pythagorean, it's not a right triangle. And because it's a no here, because it's not a right triangle, it definitely can't be a Pythagorean triple. But not only because of that, if I look at my numbers here, none of those are counting numbers. So it has kind of a double whammy against it. It couldn't have been a Pythagorean triple because it wasn't a right triangle, and the numbers weren't counting numbers. Okay? So hopefully we understand everything we need to know about our Pythagorean theorem.